Today, we are going to discuss about variable and its data type in Python. So let's go through the outline of this lecture. Firstly, we'll discuss about what is variable, naming rules, examples of variable, keywords, different data types, and lastly, what is typecasting. So, coming up to the topic, let's see what is variable. A variable in Python is a symbolic name that references or holds a value. Once a variable is assigned a value, it can be used throughout your code to represent that value. In essence, variables allow programmers to store and manipulate data within their programs. Understanding this fundamental concept is crucial for writing efficient and effective code in Python or any other programming language. To create a variable in Python, we simply assign a value to a name using the equals operator. No need to explicitly declare the variable's type. Python can figure it out automatically. For example, let's say x equals to 5, which represents integer variable, while names such as Alice, Krishna, Binal stands for string variable, while the variable which describes precise values such as pi equals to 3.14 is considered as float variable. And lastly, a variable having two results, whether true or false, is considered as boolean variable. After discussing about declaration of variable, let's go through the variable names. When we create a variable which is like a container for data, we need to give it a name. Here are some rules for naming variables in Python. First, let's start with a letter or underscore. Variable names must begin with a letter or an underscore. After the first character, we can use letters, numbers, or more underscores. Second, case sensitivity. Be careful. Python treats variable names as case sensitive. For example, name with small n and name with capital N are different variables. Third, avoid reserved keywords. Some words like for, while, if, etc. have special meanings in Python. We can't use these reserved keywords as variable names. Fourth, variable length. Variables can be of any length, short or long. It's up to you. Fifth, no special symbols. Avoid using special symbols like exclamation mark, hash, at the rate, percentage, and so on in variable names. Coming up to the examples, the following examples shows whether a variable is valid or not. Keywords. Keywords in Python are reserved words that cannot be used as variable name, function name, or any other identifier, such as and, as, assert, break, false, class, etc.
Let's talk about data types in programming. Imagine you have different types of containers to store things. Similarly, in programming, we have different boxes to hold data. These boxes are called variables, and each variable has a data type that defines what kind of value it can store. Here are some primitive data types. First, integer. It is used for whole numbers. For example, age is equal to 25, year is equal to 2024. Then, float. It represents real numbers with a decimal point. For example, temperature is equal to 98.6 and price is equal to 19.99. Then, string. The sequence of characters enclosed in single, double, or triple quotes. Strings are immutable, meaning their contents cannot be changed after they are created. For example, name is equal to Alice or greeting is equal to hello world. And at last, Boolean. A Boolean represents one of two values, true or false. Think of it like a switch. Either it is on or off. Booleans are essential for making decisions in programming. For example, is raining is equal to true. Is sunny is equal to false. Is raining is equal to true. It means it's currently raining. And is sunny is equal to false. It means it is not sunny. Even booleans are often used in conditional statements. to control the flow of a program. For example, if it is raining, take an umbrella. Let's dive into the concept of composite data types. First, list. Think of a list as a collection of items, like a shopping list or to do list. The items in a list have a specific order. You can change, add, or remove items from a list. Lists are defined as square brackets. Example of list are given below. Second, tuples. Imagine a tuple as a fixed set of values like coordinates, latitude, longitude. Like list, tuples also maintain order. Once you create a tuple, you can't change its content. Example of tuple is given below. It is defined by parentheses. Remember, lists are flexible and allow modifications, while tuples are rigid and unchangeable. Third, dictionary. Imagine a dictionary where you look up words and find their meanings. In Python, a dictionary is a collection of key value pairs. Unlike list, dictionaries don't have a specific order. It consists of keys and values. Keys are like the words in our dictionary. They must be unique and immutable, like strings or numbers. Values are the meanings associated with the keys. They can be of any type. A dictionary is declared using curly braces. Example of dictionary is given below. Here, name, age, and grade are keys, and Alice 25 and A are their corresponding values. 4. Sets. Think of a set as a collection of unique items, like a bag of marbles where each marble is different. Sets don't maintain any specific order. Sets don't allow duplicate values. It is defined by using curly braces or the set function. Example of sets are given below. In fruits, we have unique fruit names. In unique numbers, duplicate are automatically removed. Remember, dictionary are great for mapping keys to values, while sets are useful for ensuring uniqueness. Now, let's discuss about advanced data types in detail. First, none type. Think of none as an empty box. It represents the absence of a value. We use it to indicate that a variable has no assigned value yet. For example, x is equal to none. Here, x is like an uninitialized container. Second, bytes. Imagine a sequence of bytes like a stream of data. It is used for binary data. For example, files, network communication. It is immutable. Once created, you can't change its content. For example, data is equal to b hello. Data holds the bytes for the word hello. Remember, these data types serve specific purpose, none for uninitialized value and bytes for handling binary data. Third, byte array. It is similar to bytes but mutable. It is used for handling binary data. You can change its content after creation. For example, mutable data is equal to byte array in bracket b hello. Here, mutable data holds the bytes for the word hello. Further, moving on to type checking. Imagine you are sorting a collection of objects. Before you perform any operation, you need to know what type of object you are dealing with. In programming, type checking helps us to understand the data type for a variable. It ensures that we are performing appropriate operation based on the variable type. The type function. Python provides the type function to check the type of a variable. For example, x is equal to 5. Here, x is an integer. Type checking helps prevent errors. For example, you wouldn't add a string to an integer directly. It ensures that function receive arguments of the correct text. Dynamic typing in Python allows flexibility, but type checking keeps things in check. Next, typecasting. Imagine you have different containers that can hold different types of things. Typecasting is like transforming one type of thing into another. For example, turning a string into an integer or vice versa. Built-in functions for typecasting. Python provides several built-in functions to perform typecasting. First, int converts to an integer. Second, float to convert to a float. Third, str converts to a string. Fourth, list convert to a list, and so on. For example, let's say we have a string containing the digits 1, 2, 3. We can convert it to an integer using int. Typecasting ensures that we are working with the right data type for a specific operation. It is crucial for handling user input, reading files, and performing calculation. After discussing about typecasting, let's go through the immutable and mutable data types. Immutable types. These are types whose values cannot be changed after they are created. For example, int represents integer, float represents floating point numbers, str represents strings, tuple represents ordered, immutable collection of items, bytes represents sequence of bytes. It is often used for binary data. Mutable types. These are types whose values can be changed by creation. For example, list represents ordered mutable collection of items like a shopping list. Dict represents key values pairs like a dictionary. Set represents unordered unique items like a bag of marbles. Byte array similar to bytes but mutable, used for binary data. Immutable type ensures stability, while mutable types allow flexibility. Thank you for watching. I hope this video helped you to understand variables and data types in Python. Don't forget to like, share, and subscribe for more such content.